most out there teams from the hackathon.
Is that true? I don't know.
Well,
could be.
It certainly didn't help you, or maybe it did help you with the way Jan Peter was, screw the 100-day plan and screw business models. We're going to get into that later, but just, what was it? Build epic shit, I think you said.
And I think it got even more epic, but that's kind of what I'm going to explain. So, because
in which case, I'm going to get off your stage because I want to hear this. Thanks.
So yeah, what you told, 100 days, right? But it felt like it was already half a year ago, and I will explain why. But first of all, so how does this work? Okay, click. So, sorry? Okay, back. So what have we done? I'm going to explain a little bit more. Our plans. So what is the roadmap that we're pursuing? What are we looking for? What kind of partners and who do we speak with? And what do we need? And that's going to be for the last. It's also open for discussion. Thank you. So building Grex. So basically this is a world map, and within 88 days, we started here, right? We started in Groningen, Netherlands, but we did our first presentations here. And then we got asked by Vinay to present in London, and we went to London and we gave a presentation there at the first Blockchain in Space conference, which was amazing. We got a lot of traction. And then I hear you saying like space. Yeah, space, indeed. So there's a little pivot in our ID. And you see a little dot in New York. I went to New York. I went pitching the idea in New York to multiple organizations during consensus. And again, a lot of interest. We went to Hanover. And we went to Hanover together with Jan Peter, spoke with a lot of industry partners and to see what was happening. And then we went to Berlin. We went to the meetup of BigChainDB because we tested BigChainDB and we wanted to announce what we did at to the community, what we did with BigChainDB 2.0, and also talk about the next steps because there's such a great ecosystem in Berlin. So you can find me in Berlin every 2 weeks from now, because every 2 weeks from now I'm 2 days in Berlin, because from Kryha we also do a lot of projects, but also because we're working on Grex. And then the yellow dots, who are we talking to and where are we talking to? We're talking to people in France, because in France we have a lot of aviation industry, a lot of drone stuff, a lot of space stuff. Same goes for Switzerland. So we're talking to people in Switzerland, talking with people in Houston, NASA, that kind of people. San Francisco, because VCs got interested. So here you can go, right? So this is how we have been building Grex. We've been building all sorts of connections because that was the reason why we wanted to do this. We wanted to put ourselves on the maps, and we wanted to put Grex on the map. And for the people who don't know what Grex is, so you see a lot of more dots. Oh, that's the dot on the upper top part. That's Boston. In December, we will be presenting Grex at the Robotics in Blockchain at MIT. And that's something that we're really proud of. So that's something that's really cool. And that all thanks to the hackathon. But what was the pivot? Because I'm talking about this pivot. And so for all of you know, we started with drones. So Grex was made to make drones communicate and store data in a swarm. But during all the research that we did, we found a few problems. And those few problems can only be solved if we aim higher. And also the other one is literally aim higher. And one of the points was, so why did Tesla start with an expensive car? Because they needed an expensive car to get a lot of resources and get out there. We thought, like, well, let's apply that model too. So it's called Grex in Space. Because there's a big problem in space with satellites, and especially with microsatellites, and I will explain a little bit why. So what's the problem? Access to space data is limited to a few. Only a couple of people, a couple of organizations are able to use this data. And for universities, it's also hard to access this data because it's just centralized at different locations. But there are multiple satellites that provide similar data, data gathering and that kind of stuff. So why don't we open it up and make it in a distributed network so that everybody can have access to this data and do analysis? So we can speed up, for example, global warming research, but we can speed up maybe all sorts of other GPS problems, and we open this up. It's very expensive because it's limited to a few. And we have the Kessler syndrome, because the more satellites we launch into space, the tighter we get to the Kessler syndrome. And the Kessler syndrome says, if one thing breaks and we get debris, and then it hits another one, and then before you know, all the satellites are ruined. So we need to stop sending satellites into space, but we need to start connecting them all together in a decentralized way, so that there's no failure and that you can all connect them to each other. And also for the drones, because the drones need the information that the satellites are creating. So that was the reason why we made the pivot, because we first needed to solve another problem before we can make the drones work on the Earth. And that was the reason why we made the switch. So this is a picture of the actual problem, right? but this is actually a little bit exaggerated, but if we go on, it will look like this. But how it actually looks like is, it looks like this. So you see all the little dots, and these are all little satellites, big satellites, small satellites, all across the Earth, maybe 50% of them doing the same, GPS or pictures or whatsoever. But that's the problem that we're aiming for. So what's the solution? A self-sustaining decentralized platform for space data, so that everybody can have access, everybody can use it, and that we can, for example, if we want to send a swarm of drones onto a mission, that it can use the space data that is generated by the connected satellites, we can retrieve it, we can put it into the drones, and we have a fully autonomous swarm. A swarm of satellites, but also a swarm of drones. Click. Save money by using Grex for space data, because it's a big money saver. Get rewarded for contributing to the network. So there's also a token mechanism in here. And avoid the Kessler syndrome, because sharing, it is a decentralized community, so we're avoiding to send more satellites into the space. So, and network of small satellites for the data aggregation. So we built a roadmap for this, and I want to catch a little bit on Dimitri's talk, because what we see, we can build everything on our own, but that's not the point. There's already so much out there that you can use, and that's so important to think of. So while we're building the roadmap, we saw, okay, in order to start, we first need to have Grex.network. And you're thinking like Grex.network. So we have a guy in our team, he is addicted to buying domain names. He literally bought all these domain names. So you're now going to see 5 domain names, he all bought them, but it also explains the complexity of the stuff that we're trying to build, because we first need to build a network of data storage, because the first thing that they're going to do, they get data, they need to store it in some way, and they can also need to be indexed so that you can search the actual data. And then the second part is, you need to have a marketplace where you can have access to the data and where you can have a token to access the data or access a satellite for a certain function. And that token can be given to certain people, certain universities, certain individuals. And then you need to have a foundation in place for the governance, because without governance, the system will not exist. And you can see this as a DAO. Also, as Dimi was explaining, a decentralized autonomous organization where all the satellites are autonomous agents, actually. So basically, that's how you build a foundation. And then you get Grex.world. And you have a peer-to-peer world state of what's going on space data. And that's that part. And then we get Grex State AI. And then we get back to the drones. Because then we have a system in place where we can enable the swarm of drones to fly in the world and have trusted data to share. So this is basically the roadmap that we're pursuing. We have built Grex.ai. We're now building Grex.network. We're partnering, or together with Dimi, we're sort of brainstorming about the whole Grex Foundation and Grex Marketplace. Because you can probably imagine, you can all use existing technologies here. And what we want to do, we want to glue them together. Because, go back. We want to glue them together because you have Grex.network. So basically you can use IPFS for the file storage of all the data that's shared between all the different satellites. You can have access control and synchronization of the data by using Tendermint. You can have the foundation and the data marketplace by using Ocean. You can have the full world state stored on BigChainDB, and they can all be connected with each other. And then at the end, you have Grex.ai. And we want to be the glue or the aggregator between all these different platforms and make them all work together. And this is something that we're researching together with all these different platforms. And that's also the reason why we go to Berlin, brainstorm, pitch, etc. And then you get Grex.space, basically. Because then you combine them all together, and that's how you get Grex.space. So you basically have a satellite, and the satellite can be installed with the system, and it can store the data, it can exchange the data, and that's how it works. And you probably think like, whoa, maybe this is bullshit or doesn't work. Space companies are looking for this. We found out that they're just like asking for this. We presented to them, we presented to a few companies, and they said like, okay, we definitely need this because we're sending too much into space. We need a marketplace where everybody can access this data, and we can speed up research, we can speed up all sorts of other things, and there's a big need for this. Secondly, there's also a market for it, because if you Google microsatellites and the growth of microsatellites and the growth of the microsatellite market, you will see an increase of 50 to 100% in revenues, but also in market size. So it makes sense to start such a system. And for example, India, the government of India is also using a lot of space data, so here you can go on, and it actually makes a whole lot of sense to make this system, and that's what we realized during the research. So why? It's decentralized and distributed by design, because all they are already there, all the satellites are already there, and they're already decentralized, but only we want to connect them to each other so that they can communicate. And access control is managed on the satellites themselves instead of here on the Earth. So it's managed by the network itself, and you have a token and you can access it. So what's the approach? So back from the technology and more into the business side of things. So how have we been going on? So we're now more in the intake phase where we do a roadshow, we go on for awareness, get engagement with all these different parties. And if you look at the different parties, so we have space companies, we have clients that want to buy space data, and we have universities, because universities want to use the data, but also collaborating with the space companies. So we have a whole lot of them in our first tunnel, and then we go to the second one. And that's the phase where we're in right now. We're doing the calculations, we're looking at companies providing commitment, and we're also starting to do the value calculations. So next week we have a meeting with a company called ISIS, funny enough, and they launch microsatellites, and they wanted to help us to make the actual calculation for how much can this earn, and how much can this save, and how much can this maybe potentially solve certain problems. And then the one other part is getting investors. Because we are investing in it right now as Kryha. So we have 2 people, full-time, senior people running this. So all our profits of our company are now going there. So you could see me not sleeping for the past 3 weeks, because if I look at the financials, I don't get very happy. But there will come a time that we need external money to fund this, because we're now funding it all on our own. It's pretty damn expensive because we're traveling everywhere, but we get a lot of energy from it. But there needs to come a moment where we get the investors in. But the most important part is that we still keep engaged with these clients, because we want to have a client, a space company, and a university from the beginning using the system, because we're not going to build something that's not going to be used. So we need to get them on board, and that's all why the whole selection part is there, because we need commitment from these parties in order to actually build this. And then hopefully at the beginning of 2018 we'll start the complete development of the first 2 blocks. And that's a little bit of the roadmap and the approach that we are in right now. So you see, July, August, that's already in right now. We do a lot of awareness. So for example here, but Jan-Peter is also helping us, and Rutger also. September, October, we're getting into the workshops with hopefully the space people and also with some clients. And in November, December, white paper, design and travel, and get some VCs aligned. But in the meantime, we're already in discussion with them, so we'll keep on iterating. And then at the end, in 2019, we have 3 parties involved, and they're going to launch the system. So what do we need? So who are we talking to? So these are kind of companies that we have been talking to in the past 81 days. So from ESA to Materium, TU Delft, Catapult Satellite Organizations, Dutch aviation industry. But it is still very centralized in the Netherlands. But we're aiming for this to be an international project and not a national project, because we don't think it makes sense to make it just a Dutch project. So who do we need to talk to? And who do we want to talk to? And that's why we want to ask your help, or your network's help, or whatsoever. We want to talk to NASA. We want to talk to SpaceX. We want to talk to Google. We want to talk to Amazon. We want to talk to Protocol Labs. Protocol Labs is the company behind IPFS, storage, etc. I want to talk to Juan Benet and ask him the question, how can we make IPFS work in this system? So if you have any connections with Protocol Labs or with Juan Benet, please let us know. We want to go to Carnegie Mellon, one of the best robotics universities in the world, and want to pitch them their idea. Because one of the problems with robots in swarms is, how can you trust the other robot in a swarm? And that's not what they have solved yet. They can communicate, they can share, they are a mesh, but they didn't solve the problem of trust yet. And that's what we try to solve. Companies that can buy space data, research institutes that use space data, and if you Google and you see what kind of companies are all buying space data, it's actually amazing. It's like the most strangest company, they buy space data. Agriculture, think about agriculture. They buy a whole lot of space data. They buy a whole lot of these kind of things. National Geographic for photo expositions or research on global warming, etc. So you need to find these companies, understand their needs and how they want to access this data. So what are our lessons learned? And this is, I think, Thomas really will agree with me. So we're building one startup, and it was 1 year and 2 months ago since we launched Kryha. We started with 3 people, we're now with 12 people. So this is already gives us a headache, and then we're trying to launch an even bigger one. So you see, so this is the lesson that we learned. We're really going to do this, but it's increasing our work. I'm now working almost every weekend to make this happen, because during the day I get discussions about cracks, and in the weekends I need to do administration. So my lessons learned, it's cool to do a hackathon if you're not launching another startup. But if you're already launching a startup and you win, and you launch another one, it even increases the work capacity that you're in. So that's the lesson that we learned. We don't regret it, definitely not. But think about it. This is what we learned. If you participate in a hackathon and you are in to win there, watch out. Because if you win, it will increase the resources that you need to spend. So that's important. And that's basically my presentation on R&D, what we have done, etc. And questions?
Wow. Just wow.
Yeah, there's still no complete wire through the whole story, but we're working on it.
Wow.
Yeah.
Let's see if we can grab that catch box for you. Where did it end up? Here it is. I won't throw it as you're so close.
If this works the way you want it to work, how much less satellites could there be in the space? So if I see this picture, I think, oh my God, it looks like when you are in a tower for aircrafts. How much less could there be? Because it's a lot of trash in the space also from all the satellites which broke, etc.
So that's a very good question, and that's the question that is actually in our assumption list. Like, does it get rid of more satellites? And that's something that we're researching right now. So that's why we want to collaborate with universities, because they have the data on like how many satellites are there, and what if you can share similar satellites, how many less satellites do you need to send in space. So I don't have the actual number, but you could maybe assume that it is, let's say this system works from 10, 15 years from now, and you can use multiple satellites for the same activity. You could say that there may be 10 to 15% less satellites going into space due to the fact that they can communicate with each other and share data with each other. So,
wow, just the cost saving on those satellites alone sounds tremendous.
Yeah, could be, yeah.
They can't be cheap.
Yeah. How far are you off actually from full-scale implementation? I mean, technically, how difficult is this? He's saying that NASA hasn't cracked it. Many very bright people haven't cracked the problem at, in Boston that operates swarms. So you have cracked it, or how far are you away from it?
I think we're 2.5, 3 years away from a first initial test. And because we're not going to build it on our own. And that's why we want to use the universities, and that's why we want to use the community, because Dimi can help us with the data marketplace part, they're building that, and we just want to connect everything together and make sure that everything goes well. And why the people didn't crack it, blockchain is just a new thing coming up, and we thought that we found a solution for a problem that's out in swarm robotics, and that's why we think we have maybe a little bit of a golden nugget.
So in your roadmap, what I was also looking for are the use cases that can be built on top of it, like already mentioned, agriculture. Can farmers use directly space data in the systems they want to operate to optimize to grow the crops and stuff like that? Maybe locate swarms of locusts and protect them in time. And are you also talking to these kinds of organizations that can connect you to these real use cases that give also an image on what the impact on Earth could be if you decentralize the access to all the satellites, basically?
Yeah, so we just launched a work stream called Data Types. And Dan is now actually researching and discussing with the different organizations, like, okay, what kind of data types are we there? We have imaginary, like image data, video data, and that kind of stuff. And then you can connect these different data types to different use cases. So for agriculture, you can just use the image data. But for example, for maybe global warming, you can see spectral analysis of what the chemicals that are in the air, the CO2, how much, and which location, whatsoever. So we do it a little bit the other way around, so define data types, which is the easiest data type to get the product running, and then go find the use cases with the clients, and that's why we have also the roadmap like that.
Perhaps a suggestion is to assemble a couple of ambassadors for this You know, we will be talking with André Kuipers in the next couple of months, but maybe there are some other people that are in this space stuff, but also maybe representing the big challenges from the UN that can be significantly helped forward with this ecosystem of what you're building.
I mean, I can give you an example. I've done some work with, for example, Rabobank. You know, obviously they're huge in food and agriculture. So they know a lot about what farmers are doing and what data farmers need against pesticides and swarms and that kind of stuff. So that might be one way, if you're thinking about an organization like that sits on top of a huge user base. You know, they're desperate to provide new value to their clients. You only have to have one set of conversations instead of thousands. Anybody else got a question or comment or, yeah?
Yeah, so regarding the marketplace, that implies there's a bottleneck for accessing the data, because otherwise it'd be like a repository, like here's all the data from the satellites. For the marketplace, what is that bottleneck that people are trying to limit access to? Is it access to the big satellites that are like pulling the satellites in the sky, or?
Something we didn't figure out yet. Just
Okay.
honestly, if we figured this out, then we already had the answer on the whole data marketplace example, for example. But
Okay.
we were more focusing on like how can you, the first step, right? The P2P file sharing, and how can you make that work, and how you can let them connect with each other and get rid of that problem. But probably Dan knows a little bit more about your question.
Okay. So yeah, more just like what is like the supply and demand that you have to find the equilibrium of, because otherwise you just
So
hopefully just give all the data
how
away.
much data do you need to get this marketplace running, and how much users do you need, for example, to get like everything running? Is that a little bit of your question?
Oh, more I'm asking, like what is the price of the data? Like, because if it's data that's being pulled from the satellites, there's a reason you're not just giving it away for free to like the world. So then what is that bottleneck that people are paying access to get? Is that like?
Very good question. Very good question. I
Okay,
don't
cool.
know.
I'll ask Dan.
No, yeah. So if you have an answer on this, or you have any inputs for this, please share it with us.
Okay, cool.
Oh, we've got a whole bunch of hands going up. We're now standing between you and coffee, so I'm going to take the easy one right down here.
Hi, my name is Denise. I found this very, very interesting, and I work for IBM, and many, many years ago, we also went into space when we put the man on the moon. So are you already in contact with NASA, or?
No, we want to get in contact with NASA. Definitely.
Because I am almost positive that we've got contacts in that space as well, but that's obviously on a worldwide level. I work in the Benelux, but if you want me to help out, I can.
As long as
I can
IBM
check
doesn't matter
internally.
that we don't have Hyperledger in the project, I'm fine.
Now that's not why I'm mentioning IBM.
Fabulous. Okay, sounds like you guys should
No,
have
but
a chat over
definitely,
coffee.
If you want me to help out, I'm here.
No, definitely. I'm joking.
I'm
but
not
no,
promoting Hyperledger, I'm promoting space data.
No.
Yeah.
I just made a funny
Okay.
meme
Cool.
joke in the
All
blockchain
right.
space.
That's fine.
We're through the awkward bit now. Fabulous. Thank you for
No,
that
thank
offer.
you. Would love to.
Yeah, it was you.
So I didn't get this quite clear. So what's the point of the satellite swarm? Is it just for the collision coordination thing?
So no, not only for the collision part, because each of the satellites has a unique function. And why would you send more and more satellites into space for that unique function if there's already one there? So if you can connect that one to the network, then you can aggregate data from that specific satellite instead of sending one new one in space.
Yeah, okay, so that's a redundancy question, but that's, isn't like the market already working on that? Like if you, because it goes back to like the marketplace, I don't understand why you need some P2P swarm thing. If you can just have an easy way for me to pay somebody for data from his database that he received from his satellite, and then you have a marketplace where the data is nicely indexed, right?
Mm-hmm.
Then the market has enough information in order to reduce this redundancy. So because I'm not going to invest a lot of money into a satellite to perform a function that some competitor is already doing, and I'm not sure I'm actually doing a better job of. So I don't see the connection between this peer-to-peer swarm of satellites and the marketplace that you're creating, because I don't see that connection.
The data that's now currently provided is provided by centralized parties, and we want to distribute all that data to other people so that it's easier to access.
Right, you do that via a marketplace, right?
Sorry?
You do that via a marketplace.
What do you mean? You do not find a marketplace?
We say we have X and Y data.
Mm-hmm.
I just do a micropayment, receive the data, done.
Yep.
So I think it's an and. So he's saying, okay, the satellites already exist, you're getting the data from the satellites, you can throw that into a marketplace without having to do the whole swarm thing. So what's the value of the swarm thing if it's not directly contributing to the marketplace?
Good question.
That was your...
Right.
Yeah.
That's a good question.
I think...
I don't have the answer on this.
Well, I mean, I think you did give the answer, and that is, hey, you've got the Kessler syndrome coming up. We've got, satellites that don't necessarily know where they all are because they're, sort of controlled by different parties who sort of collaborate at the moment, but it's still sort of centralized and owned and proprietary. So,
yeah, you could say so. Yeah.
So I think that's where he was hinting. Can I grab the mic?
But please send these questions. So, Haisho and Dan, they are technically responsible for the project. Please send the questions to them. I'm just very honest, right? Because I'm not going to answer stuff that I don't know.
I don't know is a fantastic answer. Rutger, you're holding up coffee, so go for it.
Sorry. So there's the CEO answer right there. Do my tech guy.
Microphone.
All right, so here. So actually, we just came from a hackathon in Brussels, and you guys were there as well. And there was this team that was working on how can decentralized owned satellites contribute to fighting anti-counterfeiting. For example, if you know if a shipment has to go through a certain route and you have proof of that, and a ship diverges from it or slows down unexpectedly or what have you, okay, you can now mess with the GPS data easily. So proof of data or established proof of certain findings from a satellite to begin with can be very, very interesting. So then you don't have a GPS coordinate, it's also proven that this GPS coordinate was correct.
And from multiple corroborating sources.
Stuff like that, so that it's proof of outer space, I would say, instead of a proof of something. So there's an interesting angle. There's also the angle of the centralized ownership of satellites. It doesn't only bring all kinds of problems in space, but the fact that okay, so what steps do I have to take to now use data from any satellite in apps I want to use, right? I want to have that at the touch of the button. That's also, I think, you need a protocol for that. So what if we could launch a satellite network easily ourselves?
Maybe Haisho can answer it, because...
And I'm thinking we should do that in coffee.
Yeah, sure. Because you started with autonomous drones. How can drones own themselves, coordinate autonomously, like nodes behave in a blockchain network? And I think that's the point where you start thinking about how can things coordinate themselves in networks for the benefit of society. That's the whole question put forward. So I think it's interesting that this is just a different paradigm, but also to really make a separation of how that paradigm is different from what we already have. The stuff you have in your presentation is awesome, but I would really like to see how it changes the world from what it is right now.
But that vision of a new future.
Exactly. And what can you build on top of the new future instead of, I mean, you're bringing the world of today to tomorrow, not the world of yesterday to today, right? So that's really also...
Next 100 days.
Yeah, good tip. Right. Fabulous. And you've still got 19 days left over for your first 100.
Good luck with that.
Ladies and gentlemen, I hate these things. We are out of time. It is coffee time. Thank you so much to the guys from Kryha. Haisho is now here as well. Wave.